Hello my dear students, I welcome you to NEET-1. So today we will be discussing about types of chemical reactions. This is from class 10th chemical reactions and equations chapter. Okay. So in the last video we have studied about law of conservation of mass, right? Okay. So now during the class what we studied there, so reactants will combine to form products. So here the elements which are present in a particular compound, what? The atoms of an element which are present in a particular compound, the reactant side will reorganize and form some product, right? So this combines, reactant will combine and forms product. Okay. So during this process atoms neither be created nor be destroyed, but they will be getting reorganized, right? Okay. So based on that we will be also having some other chemical reactions, like some chemical reactions here. So let us understand them. Okay. So types of chemical reactions here. So we have combination reaction, next decomposition reactions, and the next displacement reaction and double displacement and oxidation redox reactions. So let us start our topic with our combination reactions. So the word itself saying combination. So when the reactants, like reacting species will combine, like they will combine, like here see a reaction in which a single product is formed. What they are saying, a single product is formed from the two or more reactants. Let us say I have A and B are the reactants, these two are combining and forming some single product, like AB is a single product, right? So this is a basic way of understanding the definition of combination reactions. So let us say I have carbon, okay, so upon combining with oxygen, so it will be forming CO2. Yeah, we got a single product when carbon and oxygen is combining. So let us, this is one of the suitable and simple example for combination reaction. I hope it is clear. And see here, calcium oxide reacts vigorously with water and produces slake lime, that is what calcium hydroxide, so releasing large amount of heat. Yes, so we know whitewashing, so we used to do whitewashing to the walls, right? So to the building or to the house, so what we can see, so people are doing whitewashing, right? So we'll see the chemistry behind this also. Okay, so there generally what happens, so we'll be having calcium oxide. Okay, so upon treating with water, when this calcium oxide is placed in the water, so it will be forming some so it will be showing some exothermic reaction. It means if we touch that container in which the water is there, so where we are keeping the calcium oxide, so what happens, we feel very hot when we touch the container of that mixture, so it will be producing some heat. So CaOH twice is produced, I mean this is formed, and along with this some heat is released, which I am indicating with symbol delta. So it represents that heat is released during the process. Okay. Now when in a reaction if heat is released, what we can say, it is a exothermic process or exothermic reaction. Okay. So now, so here this substance, this CaOH twice is formed now, so that we can say slake lime or calcium hydroxide. Okay. Okay, I hope it is clear here. The next, see, a solution of slake lime produced by the reaction is used for whitewashing. Yes, so what we got here in the previous reaction, what we got, slake lime is got now, we got now calcium hydroxide. So this will be used as a used for whitewashing purpose. Okay, so now for whitewashing, so what they will do, the person will subject, like they will do like they will apply it on the walls, right? So this calcium hydroxide will be applied on the walls, right? So now this solution, when it is exposed to carbon dioxide which is present in the atmosphere, so what happens, so there will be a very slow reaction between the calcium hydroxide and CO2. So within 1 or 2 days we will be seeing a very solid mass like calcium hydroxide, which is having calcium carbonate, CaCO3 we can say. So this is a solid mass, will be having very shiny white appearance, right? The walls will appear very shiny with very glorious, with white appearance, right? So that is what the calcium carbonate is formed after 2 or 3 days of whitewashing. So this gives what, shiny finish to the walls. And interesting to note that the chemical formula of marble is also CaCO3. Yes, we will come back to that. So what we studied here, the slake lime, calcium hydroxide, which formed from the calcium oxide when dissolved in the water. So that is what the slackle lime. So when it is applied on the walls, so what happens, the slackle lime which is applied on the wall and the carbon dioxide which is present in the atmosphere will get reacts, will get combined and will form calcium carbonate. Okay, so this is a solid white substance which is appears on the wall and which is responsible for the shining. What is that? Which is having a shiny finish, right? So this is also you can understand from this. Okay, so this is a general life application where we will be seeing in our daily life, right? Okay, so now one more thing also mentioned here, the marble. What is the marble chemical formula? If someone asks you, so you can give it as calcium carbonate. Okay, so one more thing you can remember, the famous monument, the historical monument we know, Taj Mahal. So Taj Mahal is also what? They built it using the marble only, na? So that is also having CaCO3, right? Okay, so now some days, sometimes we will be hear a word that, so these marbles will be affected by the acid rains, right? So Taj Mahal is affected by the acid rains. So what happens here is, so due to the acid rains, so that will disturb this CaCO3. So this calcium carbonate will be there now. So this is a solid substance now. It's a marble, right? So whenever acid is falling on this, so it will get affected. This calcium carbonate will get affected by this acid rains. Okay, therefore the Taj Mahal is getting affected by the acid rains. I hope it is clear here, right? Some more examples of combination reactions here. So first one is burning of coal. So just now I explained carbon, oxygen forms CO2. So this is what? Burning of coal, which is a combination reaction example. See, formation of water, H2 plus O2 gives rise to H2O. Here we should take half mole for every 1 mole of this H2. So if you take 1 molecule of H2, we should take half molecule of O2, therefore we will be getting 1 molecule of water. So this is what the formation of H2 reaction, H2O reaction, formation of water. Okay, and the next here we can also see the combination. See, in the first case, combination between the two different elements like atoms, I can say carbon atom and oxygen molecule here. So between here two different elements like oxygen and hydrogen molecule and oxygen molecule here we can see. So now we can also see the combination can be between the two one atom and also one molecule, or between two molecule also we can see. So now just now we have seen calcium oxide is one molecule and water is another molecule. Between two molecules the combination reaction is taking place and forming it as CaOH twice. So this is also combination reaction only now. So when two or more reactants are combining to form a single product, so we can consider it as what? Combination reaction. I hope it is clear. Okay, then next, carbohydrates are broken down into glucose, right? Okay, so these glucose combine with oxygen in the cells of our body and provides energy. The special name of this reaction is what? Respiration. So what he mentioned, so glucose combines with oxygen in our body in the cells. The next, it provides us energy. The name of this process is what? Respiration. Okay, so glucose formula C6H12O6 combining with oxygen and forming what? CO2 gas. Okay, this will be liberated out. Okay, this will be exhaled out, right? And energy is released. So that is the energy we are using in our daily life, right? Okay, then next, decomposition reactions. So here decomposition reactions, a chemical reaction in which a compound is split into two or more simple substances. Okay, so in a chemical reaction what happens? A compound will split into two or more simple substances. For example, here I am writing the basic one here. I will be giving you two examples here. So PCl5, if I say, so PCl5 is a compound. Now this compound will be splits into PCl3 plus Cl2 form. So see, a simple in which a chemical reaction in which a compound is splitting into two or more simple substances. Yes, we got two simple substances, right? So this can be considered to be a decomposition reaction like that. Okay, let us discuss few more things. The decomposition reaction requires either energy in the form of heat, light or electricity. So for this purpose, for decomposition of a particular compound, we require some energy. So that can be in the form of heat or in the form of light or in the form of heat, electricity. Okay, so it can be any of these. So the reactions which are favored by absorbing the heat are called endothermic reactions. In the previous case, evolution of heat, like when we are making slackle lime, so what we observe, heat is released, right? So that is exothermic. So here decomposition reactions require some energy to be consumed, right? Therefore the reaction takes place. Okay, so those kind of reactions which requires energy can be considered to be endothermic reactions. Okay, what is that? Endothermic process or endothermic reaction. Okay, so what are the things required here? Either heat or sunlight, okay, or electricity is required. So we will be having an example of electrolysis of water, we will be seeing that also. Okay, here see, heating of lead nitrate. The first one is, let us see the example for heating of lead nitrate here. So whenever this lead nitrate PbNO3 taken twice is heated, okay, it dissociates into PbO, lead oxide, and nitrogen dioxide is evolved here. Okay, so nitrogen dioxide is having brown color, it's a brown color gas. Okay, so this can be seen. So just take the Bunsen flame. So to that, take the lead nitrate in one test tube and take it to the near to the Bunsen flame. So what happens? Due to the heat, the brown color gas will be comes out. So you have to see that we have to observe that brown color nitrogen oxide gas. So nitrogen dioxide gas will be released out. Okay, now one more thing I will be explaining now. So just remember, NO2 is having paramagnetic nature. I will tell you what is that paramagnetic nature later. So just remember NO2, which is a brown gas having paramagnetic nature. Okay, we will discuss about paramagnetic nature, all these terms later. So just having some just I want to relate you to some basic terminology which we are going to use in the later sessions. Okay, the next, a decomposition reactions carried out by heating is called as thermal decomposition reaction. So if the process is carried out by heating, so this can be what? Thermal decomposition reaction. Okay, then next, here decomposition reactions due to light. Yes, some decomposition reactions can be due to presence of light. So for example, AgBr, silver bromide you can take, or silver chloride we can see. Okay, so this silver bromide or silver chloride if we take upon exposure to the sunlight, okay, so due to the sunlight, so it will decompose to the respective atom. For example, here we have silver AgBr we have, so this will be decomposed to Ag, and here it is forming Br2. So let us take two molecules, it will be giving A2Ag, and Br2 Br2 is formed here. Okay, again bromine, if it is in the liquid form, we will be having orange color solution, right? Okay, so now this is what we will be observing. Okay, so decomposition due to light is called photolysis. If the decomposition process is due to in presence of light, we can say that is what? Photolysis process. I hope it is also clear. Okay, then next, again, so out of these two process, AgCl is decomposing, AgBr also getting decomposed. Which is faster here? AgBr decomposition is faster than the AgCl. I hope it is clear. Okay, then next, these two process we have studied about photolysis process now, so that will be used in the photography. So that black and white photography will be there now. So further, both these reactions are used for black and white photography during the process of developing. Okay, so I hope this is also useful point. And next we have electrolytic decomposition reaction. So how this electrolytic decomposition reaction takes place? See here, water we have. So upon passing electricity, so when we are passing electricity through the water, so what happens? It will dissociate to respective atoms. For example, here we have H2O. It will give H2 molecule and oxygen molecule here. Okay, so if you take 2 mole, so it will be giving 2 H2 and 1 mole of O2 gas. So that will be observed. See, this is also we have a like setup here, lab setup here. So take one beaker, okay, in which water is present, okay. So now take the electrodes, okay, which are connected to the battery for electricity purpose, okay. Now so that electrodes are placed in the like test tube here, which are inverted on that electrodes both sides, okay. So now by passing this current, what happens here? So what happens, the electrodes here considered as graphite electrodes. So one will act as anode, other will act as cathode, okay. So now to this process we can make the electrolysis process little more faster by adding dilute sulfuric acid also, okay. So now what happens here is, so in one at one electrode we will be seeing, and both electrode will be seeing bubbles, okay, but in one electrode we will be having a hydrogen gas is formed, in other electrode we will be having oxygen gas is formed, okay. So now so in which compartment which gas is formed? So I told you there is one is cathode, another one is anode. So in anode compartment, in anode, at anode electrode, so oxidation takes place, therefore oxygen is formed in the anode compartment, okay. And one more we have cathode now, one more electrode we have now, that is what, cathode, there reduction takes place, therefore hydrogen gas is released at the cathode electrode, I mean in the cathode compartment. I hope it is clear up to here, right? Then let us move further. Okay, so regarding the next displacement reaction we need to study, and the next double displacement reactions we need to study, and oxidation reaction reduction reactions we need to study, okay. See, this is, yes, so up to here, so this is about the class, okay. In the next session we will be discussing about displacement reactions and types of displacement reactions, and also oxidation reactions, okay. So thank you for watching, stay tuned with NEET World, okay. So happy learning.